Chapter 1.2, Day 2, Example 2, Writing reflections of the functions. Letter A is write a function g whose graph is a reflection in the x-axis of the graph of fx absolute value x plus 3 minus 1. So what we're going to do is that for reflection we multiply the whole graph by negative number. So we are going to multiply the whole graph or whole function, that is fx in this case, by -1 or negative. So we are going to put this whole function into the bracket and multiply the negative or distribute the negative inside. So the function would be negative absolute value x plus 3 minus 1. So that is our reflection graph gx. When we multiply the whole function by -1, we get the new graph, that is gx, that is reflection of the original graph fx. So for example number 2, letter B, write a function h whose graph is a reflection over the y-axis. If you want to find the reflection over the y-axis, then you're going to multiply the inside x by -1. So only the inside negative x would be multiplied by negative x. So it means that the function that you're going to get should be negative x plus 3 plus 1. So the graph that is hx going to be your reflected graph over the y-axis, and then that graph should look like negative x plus 3 plus 1. Only the x coordinate or x value would be multiplied by -1. The next problem is write a function gx whose graph is reflection in the x-axis of the graph, and then the parent graph in this case is fx absolute value x minus 3 plus 2. Whenever we have the reflection over the x-axis, then we are going to multiply the whole function by negative. So this is the whole function and we are going to multiply it by negative. Distribute the negative inside, and then you're going to get negative x minus 3 absolute value minus 2. And when we multiply the function with the negative, you're going to get a new graph gx that is going to be reflection of the old graph fx. For the next one, let us see, write a function h whose graph is reflection in the y-axis. Whenever it's a y-axis, then we are going to only multiply the x by negative. So when you multiply this x by negative x minus 5 absolute value minus 7 would be the reflection graph over the y-axis. The next question, write a function gx whose graph is a reflection in the x-axis. Again, this is x-axis. It means that we are going to multiply the whole function by negative. So when we multiply the whole function by negative and distribute the negative inside, you're going to get the graph negative absolute value x minus 6 minus 8, and that is your new graph, that is g graph. On the next example across it, write a function whose graph is a reflection in the y-axis. Is the graph when we multiply only the x value by negative. So only the x value by negative, you're going to get negative x minus 4 plus 9, and that's your reflected graph over the y-axis. Let's look at the vertical stretch and vertical shrink on the bottom of this section. So for vertical stretches and shrinks, the graph of y equals a times fx is a vertical stretch or shrink by a factor of a of the graph y equals to fx, where a is greater than 0 and a is not equals 1. The parent function for the fx equals absolute value x. In this case, I'm taking the parent function as fx equals absolute value x. The graph of this function is a v graph, It starts from 0 0 and going to go up 1 over 1, or you can say the point 0 0 1 1 2 2 3 3, and so on so forth, and same thing on the other sides. Now we are going to get the stretch and a shrink graph. So if you multiply the outputs, output means y value, by a, stretches the graph if the a is greater than 1. So for example, if you multiply it by 2, 3, 4, 5, so on so forth, then it's going to be a vertical stretch. So when I multiply the output value or the function value by 3, then this is the graph that I got. I multiply the 1 1 by 3, so it's going to be 1 comma 3, because I multiply the y coordinate, which was 1, I multiplied it by 3, then the next point I got is 1 comma 3, because only the y coordinate will be multiplied by 3. And this is the graph that I got for vertical stretch. And for vertical shrink, the graph vertically shrink if you multiply the graph or a that is less than 1. So it means that if you multiply the a that is in front by 1 over 2, 1 over 3, 0 0.3, 0 0.4, then the graph would be a vertical shrink. Now let's look at the graph that is the vertical shrink graph. And for that graph, I multiply the parent function by 1 over 3, because anytime we multiply a number that is less than 1, that is going to be your vertical shrink graph. So the point that was 3 comma 3, so for example, this is 1 1 1 2 2 and 3 3. The point that was 3 3, now I multiply the y coordinate of that by 1 over 3. So for example, if the point, this one was 3 comma 3, now this point would become 3 comma 1. So that's why my first point is 3 comma 1 on both sides, and that is going to be my vertical shrink graph. Remember, anytime you find the points for the vertical shrink or stretch, you multiply the y coordinate by the number that is in front of function, that is a. In this case, I multiplied it by 1 over 3. I didn't multiply these two numbers because I was gonna get fraction. I carefully chose the number that is 3 comma 3, and I multiply the y coordinate of that by 1 over 3. So that's why it vertically shrunk by 3 comma 1. And I do not need too many points to graph when I graph from the parent graph, so that's why I just chose 1 point, and the second point is 3 comma 1. So that's the graph of a vertical shrink by the factor of 1 over 3. Now let's look at the example number 3 on the bottom section here. Letter A, we are going to find the vertical stretch of the graph f by factor of 2. It means we are going to multiply the fx by 2. It means that we are going to multiply the 2 with the whole function absolute value x minus 3 minus 5, and we are going to distribute the 2 inside, so our function should be 2 times x minus 3 absolute value minus 10. And we can name that 2 times fx is a new function, that is gx. So the gx, which is a vertical stretch of the graph f by factor of 2, is 2 times x minus 3 absolute value minus 10. For letter B, we are going to find the vertical shrink of the function fx by the factor of 1 over 3. So which means we are going to multiply the function fx by 1 over 3. So 1 over 3 times function fx. So function fx is absolute value x minus 3. You're going to distribute that inside. So you're going to get 1 over 3 absolute value x minus 3 times, or 1 over 3 times 3, that cancels. And then the final function would be 1 over 3 absolute value x minus 1. And we can name that new function as gx. And gx is a function that is a vertical stretch of the original function f(x) by a factor of 1 over 3. For letter C, write a function g whose graph is vertical stretch of f(x), x plus 2 minus 3 by a factor of 2. So if it is by a factor of 2, then we are going to multiply the 2 to the function f(x). So it's going to be 2 times absolute value x plus 2 minus 3. Now we're going to distribute the 2 inside. So 2 times absolute value x plus 2 and 2 times 3. So 2 times absolute value of x plus 2, 2 times 3 is 6. So this is your final answer. For letter D, you're going to find the vertical shrink by the factor of 1 over 5, where fx is absolute value x minus 1 minus 10. So you're going to multiply 1 over 5 times fx. So you're going to distribute the 1 over 5 inside the bracket. So 1 over 5 absolute value x minus 1, 1 over 5 times negative 10. It seems like it's 10 divided by 5, which is negative 2. For letter E and F, so you're going to write a function g whose graph is vertical stretch of the original graph fx by factor of 2. So if it is vertical stretch, then you're going to multiply the 2 to the function fx, and the function fx is x minus 6 plus 7. So you're going to multiply this 2 inside the bracket, and 2 times absolute value x minus 6 plus 2 times 7, that is going to be 14. So your final answer of vertical stretch by the factor of 2 is gx 2 times absolute value x minus 6 plus 14. Now for letter F, fx is x plus 2 absolute value minus 8. Vertical shrink by a factor of 1 over 4. So you want to find the function, the gx, that is vertical shrink by the factor of 1 over 4. So it means you're going to multiply the function fx by 1 over 4. So the function fx is x plus 2 minus 8. So you're going to put that inside the bracket. And now you're going to distribute that. So 1 over 4 times x plus 2, and then 1 over 4 times negative 8. So when you're going to multiply this with the negative 8, it's going to give you 8 divided by 4. So 8 divided by 4 is going to be 2. So that is the gx, your final answer.